Hello friends, welcome back to the channel. So in the continuation of our Kubernetes Day 9 services, today we are going to see a live demo of the ClusterIP type of service. Now by this point we already understand what a ClusterIP service is from the theory part. So instead of just stopping at concepts, let's perform a demo and actually see how a ClusterIP service works in real time. So as part of this demo, we are going to create a service called SEH Backend service, which will connect our backend microservices called SEH students. As we already know, a ClusterIP service exposes pods using an IP address that is internal to the Kubernetes cluster. That means this IP cannot be accessed from outside the cluster, not even directly from the master node. This is strictly meant for internal communication between pods and services inside the cluster. In this demo, we will create a ClusterIP service to connect to our backend pods, which are the SEH students pods. For this setup, we already have a deployment available for the SEH students Spring Boot application running with 3 replicas. So this application is a backend microservice that provides student details and it uses the label app is equal to SEH backend. Before creating the service, let me quickly show you a few important parameters related to the deployment. This step is very important because the service configuration fully depends on how our deployment and the pods are defined. So first, let me describe the deployment. I run kubectl describe deploy and then deployment name. So here we can validate few things very clearly. The Docker image used by the deployment, which port the application is running on, the replica set created by this deployment, and how many pods are running as part of it. You can see that deployment has created a replica set, this one, and this replica set has created 3 pods because we mentioned 3 replicas in our deployment.yaml. Now another important thing we need to verify before creating the service is the labels on the pods here, because remember, service connect to pods using labels, not the pod names. So we can validate labels in from the kubectl describe command, also using kubectl get pods --show labels. So here we can see with respect to these pods, these 3 pods, labels are type SEH backend, type SEH backend. Okay, so this command helps us to confirm which labels are attached to the pods, and we will use the same labels in the service selector. Now that everything looks good, let's write our service manifest file. Let's go back to Visual Studio Code and create the service manifest. So this is my Visual Studio Code. All the service related files will be stored under Day 9 folder of our Kubernetes playlist. So here I have created service backend.yaml file. Just like other Kubernetes objects, a service manifest also has 4 mandatory sections: API version, kind, metadata, and spec. To get the correct values for service objects, we can run kubectl API-resources pipe grep service. So from the output we can see object name services, short name service SVC, API version v1. So let's use these details in our manifest file. API version v1, kind service. Under metadata we give the service name, and this is not mandatory, but we can give service name as name SEH solutions or SEH backend service. backend service. Now comes the most important part, the spec section. Under the spec, ports is a mandatory attribute for a service and it is an array, so we define it using a dash. This also allows us to expose multiple ports if needed. Here, port is the port on which the service receives the request. This is an arbitrary value, meaning it can be any valid port number. So I am giving it 3000. And then target port. Target port is the actual port on which the application inside the container is running. So in our case, the application is running on port 3000. So we will give it 3000. So in simple terms, port, service entry point, target port, container application port. Next we specify type. If we don't explicitly mention the type, Kubernetes will create a ClusterIP service by default. Now comes the most critical part, the selector. As discussed earlier, a service is an abstraction over a set of pods and it connects to pods using labels. So under selector, we provide the same label that we defined in the deployment pod template. So if I open shstudentsdeploy.yaml, here labels are defined as type SEH backend. So copy this and the same labels we can define here. Putting everything together, our final service manifest look like this. Now, as I am keeping everything in GitHub, so I will push those changes to GitHub. Git commit -im, provide some message, updated service manifest file, and then git push. Once done, in your Kubernetes cluster, Kubernetes playlist, just do git pull. And here under day 9, my service backend.yaml is available. Now let's apply the service manifest using kubectl apply -f service backend.yaml. So we can see service SEH backend service created. To verify, we can run kubectl get service. Here you can see that the SEH backend service is created successfully and it is bound to port 3000 of the container. Now that our ClusterIP service is ready, next step is to access the SEH backend API from inside the Kubernetes cluster and see how internal communication works using ClusterIP. So here we can see the Kubernetes service. This is the default service that gets created automatically when you set up a cluster. And the second one, SEH backend service, is the service we just created. Notice the type here, that is ClusterIP. As we discussed earlier, ClusterIP services get a private IP inside the cluster. That's why we are getting a ClusterIP over here. And ClusterIP cannot be accessed from outside the cluster. That's why there is no external IP. This service will listen on port 3000 and that's the port we will use to access our backend application inside the cluster. Now let's verify what we talked about. First, let's try to access it from outside the cluster using curl command. If we do curl and then service IP :port, as expected, it won't work. That's because ClusterIP services are restricted to internal cluster traffic only. But here is the cool part. Any pod inside the cluster can access this service. Let's test that. First, let's get all the pods using kubectl get pods. And now let's jump into one of the pods using kubectl exec command, kubectl exec -it interactive mode, then pod name --bin/bash. Now inside the pod, let's try accessing the service again. We get a 404 not found. That's because we didn't specify the context path. Our backend application has a controller with the get API, so let's provide that path. So from my student controller class, copy this request mapping /get mapping. And there we go. We get the response from our backend application. Now to summarize, ClusterIP services cannot be accessed from outside the cluster. They are accessible from any pod inside the cluster, making them perfect for internal communication between microservices. The port 3000. Here is the port where the service listens for requests. The ClusterIP is the internal IP assigned to the service. As the name suggests, ClusterIP services are restricted to the cluster and they work as a stable endpoints for pods to communicate with each other. Well, one important thing to note, we can access a ClusterIP service not only by its IP address but also by its service name. Let's see that in action. Here do curl and then service name colon port is 3000 and then context. Let's copy the context from here. And there we go. We still get the response from our backend application. So ClusterIP service can be accessed either by ClusterIP or the service name. Perfect. Let's exit the pod now. Now, imagine you are working in a real project and you want to debug a ClusterIP service from your local machine. How do we do that? That's where port forwarding comes in. Just like we did earlier for pods and deployments, we can do port forwarding for services as well using kubectl port -forward service name then port. Okay, so what it is doing, any request coming to port 3001 on your local machine gets forwarded to port 3000 of the service inside the cluster. Now hit enter. And in the new terminal, try curl and then http://localhost :/API/v1/student/students. And there it is. We are accessing our backend API running in the pod via the service. Super handy for debugging. Now let's talk about load balancing. Remember, services automatically load balance traffic across all pods associated with them. Let's see that in action. First, stop the port forwarding from here and clear the screen. To make it easy to observe load balancing, let's scale down the deployment to 2 pods instead of 3. If we do kubectl get deploy, we have 3 pods running. Kubectl get pods, 3 pods are running. For that, to scale down the pods from 3 to 2, run the command kubectl scale deployment and then deployment name --replicas is equal to 2. Scale. Now kubectl get pods. Now we have 2 pods are running. Now let's get into one of the pods using kubectl exec command. Kubectl exec -it, then pod name --bin/bash. Now we are inside the pod. So inside the pod, we want to hit our service multiple times to see if the load is distributed. Let's automate this with a simple script. Here I is equal to 1 while $i is less than equal to 15 semicolon do. Here C URL I plus 1. Okay, and then done. So what's happening here? We initialize a variable I with 1. We use while loop to hit our get API 15 times. Each iteration uses curl to call our SH students microservice. I increments until it reaches 15. Now to see how the load is distributed, in the another tab, check the logs of each pod. For that, do kubectl get pods and kubectl logs -f pod name. Do the same for second pod, kubectl logs -f. Hit enter and hit enter. Now run this script. Okay, it has executed 15 times. Here we can see some requests are hitting the first pod and some requests are hitting the second pod. That is load balancing in action. So we can also check which pods are associated with the service using kubectl get endpoints command. Whenever a service is created, an endpoint object is automatically created with the same name, and here you will see both pods are associated with our service. You can validate this further with kubectl describe command for service. For that, kubectl describe service svc and then service name. So you will notice the pods listed here are the ones serving this service. The cool part is, if a pod is added or deleted with the matching label, these endpoints updated automatically, seamlessly routing traffic. And that's a wrap for today's session. In the next lecture, we will dive into another type of service, that is node port, and see how it works in action. So stay tuned. Don't forget to like, share with your friends and subscribe to the channel for more Kubernetes demos and tutorials. Happy learning and see you in the next video.